In this unit, we're going to be studying number sense. In this lesson, we'll be introducing exponents. All right, hi everybody. In this lesson, we're going to look at exponents. We're going to introduce you to exponents here. Okay, and so exponents are an abbreviated form of multiplication. So for example, 4 to the 3, okay, 4 with that superscript of 3 there means 4 times 4 times 4, and that's equal to 64. Okay, so we're going to define some of the pieces here. Power, when we refer to a power, what we mean is an expression indicating repeated multiplication. Okay, so this whole thing here, 4 with the superscript of 3, actually I think I said subscript over here, superscript, okay, this is our power. Now, sometimes we use power to refer to the exponent, but technically the number up here really is the exponent. Okay, although we use them interchangeably. And the 4 here, this is supposed to be referring just to the 4. This is called the base. So what the base is it's the number that is repeated as a factor. Okay? So 4 to the exponent 3, 4 to the power of 3, is 4 times 4 times 4. It's the base that gets repeated, and the exponent is the number of times the base is a factor. Okay? So a power indicates repeated multiplication. Now, just like, by the way, a product is repeated addition. Okay? If I've got 2 times 3, what that means is I'm going to, and there's a couple of ways I can interpret this, okay, because order does not matter with multiplication. So I can think of this as 2 plus 2 plus 2, where 2 is this value that I add 3 times, or I can think of this as 3 plus 3, where 3 is the number that I add twice. Okay, it shows up twice there. A quotient is repeated subtraction, okay? And so we can show that with a couple of different examples, but the point being here that we often create these shortcut notation, the shortcut tool to deal with something that's going to be done over and over and over again. So that's what this is. When we have repeated multiplication, the number that we're repeating is the base of the power. The number of times it gets repeated as a factor is the number that we put in the exponent. Okay? So now let's take a look at some examples where we do some evaluating and do some math with these powers. Okay, so we're going to work through a handful of examples here. And the examples that we're going to go through are really going to be designed to help not only illustrate what a power is and how a power works, but also some of the issues that pop up with the notation here. So for example, right here I've got 4 to the power of 2, 4 squared, which means 4 shows up as a factor twice. Now I usually use the dot to refer to multiplication. It doesn't really matter. And so 4 times 4 is going to be 16. So 4 to the power of 2, or 4 squared, okay, because when it's to the power of 2, we refer to it as a square, okay, is 16. Now over here, you really need to be careful with this. Okay, you need to be really careful. The exponent sits over top of the value that is the base. Okay, so in this case right here, the question is then, what is the base? Is it 4 or is it negative 4? Well, if you think that the negative in front of the number typically could be written as like a negative 1 multiplied by, then you could think of this as negative 1 multiplied by 4 squared. Now, after doing that separation, notice it's just the 4 that is the base of the 2. Okay, the base of in that power there. So this becomes negative 1, and then 4 times 4, and this time I'm using parentheses together to illustrate the multiplication. So the negative did not get repeated. the negative was not being squared. So this is negative 1 times 4 times 4 is going to be negative 16. Whereas over here, even if I did that, so here's that set of parentheses right there that I'm given. There's the 2. Okay, that's the exponent. Even if I separate the negative 1 and the 4 and make this negative 1 times 4, notice that both of these are in the base of the power. This set of brackets, the set of parentheses here, encompass the base of that square. So this really becomes negative 1 times 4, and then I do it again, negative 1 times 4. Everything here becomes a factor twice. So a negative times a negative is positive, 4 times 4 is 16, and I get 16. Now, the more comfortable you get with this and with the integers, the easier this is going to get, the more obvious that's going to get here. And so you would see this probably as just negative 4 multiplied by negative 4 without separating, the negative and the 4 here. But until you get to that spot here, the difference between these two expressions becomes very difficult for people. And we have all sorts of people that want to treat this as if it's this. And then we'll also, by the way, get a lot of people that will try to put this into their calculator and put this into the calculator instead, even though they know this is what they're looking at. It can be kind of confusing. Now, 6 squared means 6 multiplied by 6, and that's going to be 36. 2 to the 5th. Okay, well, now we're starting to play with the exponent. This means 2 shows up as a factor 5 times. Okay? And now I can just take this in pieces here. 2 times 2 is 4, multiplied by 2 by 2 by 2. 4 times 2 is 8, times 2 times 2. 8 times 2 is 16, times 2. And 16 times 2 is 32. Now, I could do that in one step. I really could. But just to illustrate how that works there, that's another way I could do that. I could just do bit of multiplication at a time. Here, 5 to the power of 3 means 5 is the factor 3 times. 5 times 5 is 25. And when I multiply that by 5, I get a 125. So 5 to the power of 3, or 5 cubed, because that's how you'd say that, is equal to 125. Okay, well now let's put this information into some slightly more complicated expressions here. Okay, so this is going to be 2 to the power of 3 plus 10 to the power of 2. So 2 times 2 times 2 plus 10 times 10. Now, we can do things a little bit quicker because we can do a lot of this stuff on our calculator. 2 times 2 times 2 is 8. 10 times 10 would be 100. Now, notice that I'm doing the powers, the individual powers here first. I'm evaluating them first before I do the addition. Okay? Powers are repeated multiplication. So I'm going to take the shortcut. I'm going to take the shortcut first. Okay? I'm going to do the bit of notation, the thing that shortcuts me to an answer first. So the power is a shortcut on repeated multiplication. Multiplication is a shortcut on repeated addition. So, and I do the shortcuts first, okay, because they simplify things quicker for me. So I'm going to do exponents before I do multiplication, before I do addition. So the very last thing I'm going to do here is add that 8 and that 100 to get 108. Here, 10 cubed is 10 times 10 times 10 minus 3 times 3 times 3 times 3. Having a hard time fitting it in there. I'm going to perform that repeated multiplication first because it's a shortcut. 10 times 10 times 10 is 1,000. So I'm basically evaluating this little shortcut first. 3 times 3 is 9. Times 3 is 27. Multiplied by that last 3 is going to be 81. Okay? And so now I'm at a spot here where I can do that subtraction. I've done all my little kind of shortcut things, and I get 919 as my final answer. Now here, I got a negative in front. Now, but remember, think back to what we were doing just a few moments ago. That negative is not part of the base of the power. In other words, that negative is like a coefficient. It's like negative 1 multiplied by 2 to the 4 plus 3 cubed. So this is going to be negative 1 multiplied by 2 times 2 times 2 times 2. And I'm going to add to that 3 times 3 times 3. Three factors of 3. So this first one's going to be negative. Okay, well, 2 times 2 times 2 times 2 is going to be negative 16. And then 3 times 3 times 3 is going to be 27. Okay? And so then 27 minus 16, which is really what this is, negative 16 plus 27. Okay, or 27 minus 16. This is going to be 11. Now here, and this is just to illustrate that it doesn't really matter, okay, what the base is. This can be 5.2. So this notation simply means it's going to be 5.2 multiplied by 5.2. And so now I'm just going to multiply those out on my calculator, and I'll get 27.04. Just like here, 3.16 to the power of 2. Now, bear in mind, based on what I had said before here, you might wonder a little bit what's going on here. Like, why doesn't that square then just refer to the 2? Remember, it's going to refer, the square is going to apply to the number that is directly in front of it. Now, the thing is, though, it's not, this 2 doesn't represent like 2. That's 2/10. The number here is actually 5 and 2/10. Now, over here, this is negative 2 to the 4. Okay, that negative refers to a number being multiplied by it. There are like two numbers here. I can see it like that. This is not negative 2 to the 4. I am going to see that as two different factors there. Whereas up here, I do see this as negative 4 to the exponent 2. But this is a little different. That 5.2, there's my full number. This 3.16, that is that full number. So 3.16 multiplied by 3.16. I just got to do this on my calculator here. Ooh, we got a big decimal here. 9.9856. Okay. Negative 5 cubed, but this is a little bit different. This is like negative 1 multiplied by 5 to the power of 3. So negative 1 multiplied by 5 multiplied by 5 multiplied by 5. Now, I already did that one. 5 to the power of 3 up here was 125. Putting a negative in front like that simply makes my final answer. Whoops. Sorry, I don't know why I missed the 2 there. Makes it negative 125. Over here, because of those parentheses, whatever's in the parentheses becomes the base. So that 3/4 gets repeated. That's my repeated factor. Now, when I multiply fractions together, remember I multiply the numerators together, and then I multiply the and I'm already in my head anticipating what that's going to look like. It's going to be 4 times 4. So 3 times 3 is 9, 4 times 4 is 16. Same thing happens here, it's just that that base shows up 3 times. And so I'm going to get 2 times 2 times 2 in my numerator, 3 times 3 times 3 in my denominator. And so that will be 8 over 27. Over here, 0.5 to the 4, well, that means 0.5 actually, I'm going to put parentheses here. I don't want to get the decimal confused. So 0.5, 0.5, 0.5. Whoops. And I go to my calculator. And in this case right here, the number is going to actually get pretty small. Okay, because it's like a half of a half of a half of a half. I'm going to get 0.0625 as my final result. Okay, now, finally, what on earth? I have a factor of 7 that doesn't show up. Because remember, the exponent tells you how many times that thing shows up as a factor. Well, what does that mean? Well, that maybe doesn't explain it enough here. So let me show you something off to the side here, and then we'll talk about what this means. So if I gave you, for example, 2 cubed, we've already seen that that means 8. 2 squared means 2 times 2, and that's going to be 4. 2 to the power of 1, that's an interesting one. That really just means that I'm going to have this 2 sitting there all by itself as just one factor. This right here is 2 times 2 times 2. This will be 2 times 2. Okay, now watch what happens, everybody, as I go from one level here down to the next one. When I go from 2 cubed to 2 squared, I am simply subtracting 1 from the exponent. 2 squared to 2 to the 1, I'm simply subtracting 1 from the exponent. Now watch this. To go from 8 to 4, I divided by 2. Basically canceled out one of the factors here. To go from 4 to 2, I divided by 2. Now, there's a pattern here, and if you don't believe me, we can go up one more level. Okay, this is going to be 2 times 2 times 2 times 2. I can go 2 to the 4 is 16. Subtract 1 from the exponent. 16 to 8, I'm dividing by 2. So the point is, on the left here, I'm subtracting 1 from the exponent. On the right-hand side, I'm dividing by 2. My next step would be to go 2 to the 0. I subtract 1 from the exponent. 2 divided by 2 is simply going to be 1. That's the result. That's the pattern. Okay? And in fact, it wouldn't have mattered what number I put in the base here. Makes absolutely no difference. My conclusion at this point is always going to be the same. So in this case right here, I might have had 7 squared is equal to 49, and then 7 to the 1 is equal to 7. But as soon as I get down to here, 7 to the 0, I subtracted 1 from the exponent. I divide by 7, I'm going to get 1. 7 to the 0 is just 1. Okay. So that is an oddball little result. It's very counterintuitive. I know a lot of people want to look at that and say 0, but it's not 0. It's actually 1. It has to be 1. Here, again, that negative, because there's no parentheses here, that negative sits on its own, and then it's 2 to the 5th, so 2 times 2 times 2 times 2 times 2. And we've already looked at that, right? 2 to the 5th, we knew was 32, so this is basically just putting a negative in front of that result, so this will become negative 32. Now this one right here, this is like negative 0.7. That negative is now inside that set of parentheses, so it does show up twice. Okay, it is actually part of the base. The parentheses here keep it as a unit with the base. So 0.7, negative 0.7 squared. The negatives are going to cancel. I'm going to get 0.49. And that's the answer that I'm looking for. Okay, hope that helps.